Today's video is day 6 video, would be Tuesday, March 31st. Before I begin, I want to talk a little bit about yesterday's video. On the right-hand side, I had the identities. The last identity, the second of the tangent, said tangent of alpha plus beta. Well, the first one was a tangent of alpha plus beta, so it should have been the last one was for the tangent of alpha minus beta. The identity is correct for that. Okay, what we're going to do today is going to be verifying these identities, and don't worry, they're a lot easier than the ones you were doing before, because anytime you see a sine, a cosine, or a tangent of any one of these sum or difference of angles, that's what you're going to work with. You're going to replace the cosine of alpha minus the cosine of beta with what it is equal to. So that's going to be the cosine of alpha, cosine of beta, because if it's a cosine, they have the same and opposite sign, so it's going to be plus the sine of alpha, sine of beta, and that's all over the sine of alpha, cosine of beta. And then we're just going to take these two terms in the top and put it over this monomial denominator, so we're going to make two fractions out of it. Cosine of alpha, cosine beta, divided by the sine alpha, cosine beta, plus, and then the other stuff. And as I'm writing this, trying to get that second step without having your identities memorized would be impossible. So I beg you to have a notebook. In fact, I'm going to require you to upload pictures of that coming soon. And please study these things. So we have the cosine of beta, the cosine of beta, they cancel out. So what I'm left with here is the cosine of alpha, sine of alpha. That is the cotangent of alpha. And over here, the sine of alpha cancels out the sine of alpha, and I'm left with the sine of beta over the cosine of beta. That's going to be plus the tangent of beta. So they work a little nicer and easier than the ones that we were doing. Okay, now we'll take a look at a different one. This one actually has an angle in it, pi over 2. But I'm going to do the same exact thing. I'm going to replace this difference of an angle with what its identity says it is, which is going to be the cosine of pi over 2 times the cosine of beta. So that's going to be cosine of theta. And since we're doing a difference of the cosine, it's going to be the sum here, because we have the same cosine, cosine, plus, and then sine, sine. We're going to do the sine of pi over 2 times the sine of theta. And just a quick memory, our unit circle, pi over 2 is right here, ordered pair 0, 1, cosine is 0, sine is 1. So the cosine of pi over 2 is 0 times the cosine of theta plus the sine of pi over 2, which is 1, times the sine of theta. Well, 0 times the sine of theta is 0 plus sine of theta, so I'm left with sine of theta, and we have verified that identity. All right, one more of these. This is the identity in question. So we got the tangent of x minus the tangent of pi over 4, and we want to show that it equals this mess over here. So the tangent of a difference is going to equal the tangent of the alpha, the first one. So tangent of x. And since it's minus, it's going to be minus the tangent of pi over 4 all over 1 plus the product of the two tangents. So it's going to be the tangent, having trouble here, of x times the tangent of pi over 4. So again, tangent of pi over 4 is here. We've got root 2 over 2, root 2 over 2 for the cosine and sine, so the tangent is 1. So the tangent of x minus the tangent of pi over 4, which is 1, all over 1 plus the tangent of x times the tangent of pi over 4, which is equal to 1. So we're finished already. That's it. Okay, before we can move on to the next type of problem, we're going to review a little bit of a problem that we did before. I'm going to give you two angles. Well, I'm going to give you the sine of the one angle and the cosine of another angle and tell you where they are. So we've got alpha, which is in quadrant 2, So we need to draw a picture of that. So over here in quadrant 2, I'm going to have my alpha. So my reference angle here for my alpha. And this, we are given the sine of this angle is 4/5. So we know that the sine is the opposite over the hypotenuse. So that's going to be 4 here and a 5 here. By Pythagorean theorem, that is going to be 3. So the cosine of my alpha is going to be the adjacent over the hypotenuse, which is going to be 3/4. The sine of beta is 1/2, but beta is in quadrant 1. So over here in quadrant 1, we're going to go ahead and draw my angle. And the sine again is also going to be the adjacent over the hypotenuse. So that's going to be 1/2. So we're going to come up with 2 squared. The hypotenuse squared is equal to the sum of the squares of the legs. And that means that x squared is equal to 3, or x is equal to the square root of 3. And we're only going to deal with the positive because it is positive. If it was we were finding over here, then that would have been a negative root 3, or a negative 3 actually. So that makes this a negative 3/4. All right, so what we're going to do then is we're going to find some other things. So I can ask you now to find the cosine of alpha plus beta. Well, that means I need to now know what the cosine of alpha plus beta is by the identity. The cosine of alpha plus beta is the cosine of alpha cosine beta. Cosine alpha cosine beta minus sine alpha sine beta. So cosine alpha we have as, we just found, negative 3/4. Cosine beta we found to be square root of 3. Minus the sine alpha, which was given to us as 4/5. And sine beta, which is 1/2. And now we're just got to play with these numbers. So that's going to be negative 3√3/4 minus, well, the 2 goes into the 4 2 times, so it's going to be 2/5. So it looks like we're going to get a common denominator here, which is going to be 20. So we can scroll up a little bit here. Maybe. There we go. And this is going to now be negative 15√3/20. Multiplying this by 5/5. And this one, of course, is going to be multiplied by 4/4. So it's going to give me minus 8/20. So negative 15√3 minus 8 all over 20. And final problem, I could ask you all kinds of other things with this, but let's go ahead and find now the sine of alpha plus the sine of beta. Oops, I need my pen, not my eraser. So sine of alpha plus beta. So the sine of alpha plus beta is going to be the sine of alpha cosine beta. Sine alpha cosine beta. And that one will be plus cosine alpha sine beta. And they do have a little flow to them once you know them. All right, the sine of alpha. So we're going over here with alpha. The sine is going to be that negative. Sine was given to me as 4/5. Cosine beta. Cosine beta we found to be, what did we find the cosine here? Root 3/2? Negative, no, positive root 3/2. Does that mean I just messed up the last one? I certainly did. Well, you have to go back and fix that last one. I can't do it with this video. The x is square root of 3. I never finished out the cosine of beta here is the square root of 3/2. and I picked up that root 3 is only the square root of beta. So it's not what I said it was. You'll have to go back and fix that up. My apologies on that one. Too long a video to remake it. And so this is going to be plus the cosine of alpha. Cosine of alpha is negative 3/4 times the sine of beta, which is 1/2. So 4 root 3 over 10. Why would I do that? Let's go ahead and change that up a bit, because I'm going to go ahead and reduce that fraction. All right, so the 2 goes into the 4 here 2 times, giving me a 2 root 3 over 5. And this is going to give me plus a negative 3 over 8. So we're going to have to get another common denominator here, which is going to be 40. So this one needs to be multiplied by 8 over 8. So it's going to be 16 root 3 over 40 plus, and here we're going to do 5 over 5 minus 15 over 40. And that will be your final answer then. You're just going to have to take that 16 root 3 minus 15 all over 40. All right, my apologies for the previous question. Just go back and fix up that common denominator there by adding in the denominator of 2 for the cosine of beta. All right, thank you. Check Google Classroom and continue to ask.